Welcome everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those still in the middle of connecting.
Hello.
Welcome everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. But I want to provide an additional mechanism to ensure any questions we miss get answered. If you visit us at aka.ms/Azure Security Community, you'll be able to ask questions on our Azure Security Forum. If you're listening to this after the fact as a recording, that's also a great place to ask questions. We always love to hear your feedback on how we can improve these webinars. You can do so by going to aka.ms/security webinar feedback. And by the way, the links that I'm just referencing that I have posted earlier, so you can have a reference there. Also, please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security webinars. While you're there, please join our community by visiting aka.ms/security community. That's the best way to answer so you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, where you can sign up at aka.ms/security private preview, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a great topic for you today. We'll be talking about Azure Security Center and the introduction to Web Application Firewall. I'd like to introduce you to our presenters, Teresa Yao and Amit Srivastava. Teresa and Amit are members of our Azure Security Center team who have a deep expertise in this topic. Without further ado, I'll turn it over to them. The floor is yours, Teresa.
Thank you. Good morning. Thank you for joining us today. In this webinar, I will start with an overview of our Azure Web Application Firewall or WAF service and how to use Azure WAF service to protect your web application globally. And then I'll hand it over to Amit, who will cover how to use Azure WAF services to protect your web applications hosted in your private virtual network. We have heard from many of our customers that it's quite challenging to protect all applications for their organization. Web application attacks remain one of the top attack patterns. There are many different types of web applications. For example, a simple web portal that need to be accessible for both internal and external users. E-commerce websites usually have some pretty strict compliance requirements. API gateways usually have a very different access pattern from a browser-based websites. Almost everybody has a smartphone nowadays with a dozen mobile applications. And more, we see a lot of organizations are migrating their critical line of business applications from on-premise to the cloud to be accessible to its distributed branch offices or to its business partners. So the rapid growth of modern applications have certainly increased attack services. On the other hand, the attack magnitude, frequency, and sophisticated level has been increasing as well. There are commonly three types of attacks against web applications. One of them is DDoS attacks. DDoS attacks is distributed denial of service attacks. Those kind of attacks usually are brute force attacks that are designed to saturate your network links and your application resources. For example, TCP SYN flood attack or UDP reflection and amplification type of attacks. Another common attack type is targeted web application attacks. They are meant to exploit web application vulnerabilities. Very common ones are SQL injection, cross-site scripting, or remote command execution type of attacks. On its own category is purposely built malicious bots. This category is usually meant to target a specific resource to gain either competitive advantages or financial gains. For example, scrapping your competitors' content and pricing. Credential stuffing to gain sensitive username and password information. And most of the time, attack is usually multi-vectored. So for example, a DDoS attack is actually just a decoy to hide a real SQL injection attack, try to steal your sensitive information from your customer database. So it's quite challenging to protect all different type of applications from different types of attacks. So Azure Web Application Firewall or WAF service is designed to help you detect and mitigate common attack types and to help you meet with compliance requirements. Azure WAF is built with our platform, so it can, with built-in high availability, it can scale up and down, grow with your applications. So it's a totally pay-as-you-go consumption model. It is platform managed, so it's very easy. I'll show you in a quick demo, just in a few minutes. You can quickly configure a web application firewall policy and associate with one of your applications. There are two deployment options for Azure WAF. One option is to deploy it at Azure Network Edge with Azure Front Door Service. So Azure Front Door Service is a application acceleration and content delivery network. So you can combine the application acceleration with web protection. Another option is to fully integrate it with application gateway. So in this case, you can protect your websites not just for external users, you can also protect your internal facing web applications. So Amit will talk about regional app gateway integration a bit more later. So you can choose either one of the options to meet your requirement. The key features we have for WAF is first of all, we have a very powerful custom WAF rules engine. You can use custom rules to define specific policies that meet your requirement. For example, you can configure a Geo Filtering rule to limit the access to your website to a specific list of countries. Or you can define access to your website only from your branch offices with known IP address ranges. Or you can define access to your website, use a combination of HTTP parameters, for example, URL, query string, headers, cookies. So it's quite flexible. You can also define size restrictions, say, my request cannot be exceeding, 2,500 characters. So you can do a combination of different match conditions to define custom rules. Also at the edge of the network, our integration with front door option, you also can define rate limiting. So you can define how many requests are allowed within 1 or 5 minutes interval. So for example, you can say for my login page, no client can send more than 100 requests within 1 minute. So this is to prevent a denial of service attack from a handful or small set of IP addresses. We also have a pre-configured OWASP top 10 rule sets. So the rule sets are platform managed. So they are pre-configured, so you don't have to figure out what are the common signatures for those kind of vulnerability attacks. We also have a pretty new, recently announced, is a bot protection capability that is integrated with Microsoft Threat Intelligence feed. I'll talk about that a little bit more in the following slides. The configuration for WAF is fully supported, use Azure standard. You can use Portal, you can use API, PowerShell, or command line, and you can use Terraform for automation as well. The logs and metrics are fully integrated with Azure Monitor. So you can access your logs through either your storage account, event hubs that can be streamed to your on-site SIEM solutions, or you can use log analytics. You can also use Azure Sentinel to build a dashboard so you can see all the events coming from WAF. Azure WAF can protect backends either hosted in Azure or can be on-premise or from a different cloud. As long as we can reach your applications, then you can use WAF to protect them. So I'm going to talk a bit more about WAF option that deployed at Azure Network Edge. We have recently announced the WAF for Part Manager. So not all bots are built equally. For example, there are some good bots. Search engine bots usually are good for you because they help you raise your rankings for your websites. But sometimes good bots can become annoying bots if the crawler frequency is very high, or if you happen to run a promotion with a lot of expected incoming traffic. You probably don't want to allow crawling during that time. So while we have the default action as allow for good bots, you can change that into block. The bad bots category, one of the input is from Microsoft Threat Intelligence feed. This feed is dynamic, so it's based on IP reputation. You can block malicious bots. We actually go down to recently to 1 hour update frequency. There's another type of malicious bots. They kind of falsify their identity. For example, they claim they are the Google bots or Bing bots. But if you look at where those bots are actually coming from, they are not from the allowed IP address ranges at all. So we identify those bots as malicious bots that you can block. And there's another category of bots, even though we have very high confidence that they are automated access to your application, but their intent cannot be verified. So we know they are the tools and frameworks for crawlers, but they are not published. So we identify those as risky bots that in the unknown bots category. So here the default action is set as log, but you can choose to change that log into block if you know that your website is definitely not expecting those kind of traffic, then you can block them. You can also just log the different categories for further analysis without taking any block action. So log will allow the request coming through and just log it in your WAF logs. So talk a little bit more about what is Microsoft Edge. So on this map, you will see every blue dot is representing one or more Microsoft global users. We have actually more than 100 million daily active users. So we are building edges so we can access our users in a very speedy way. So our users can access our services in an optimized way. So the dots you see there is our Microsoft Global Edge sites. There are more than 160 and growing. And we have over 130,000 miles of fabric. So we have a optimized, purposely built global WAN that can help our services to reach our users in a secure and optimized way. We have over 54 global regions. So the Edge services, Edge Web Application Firewall, and front door services are deployed in one of those Edge locations or in all of those Edge locations. So from end user to the Edge locations, we use global anycast architecture. So any of the end user can reach the Edge site that closest to them. So our target is to be within 25 milliseconds. And then from the network edge services location to the backend is Microsoft managed WAN. So the connectivity is optimized. When a request arrived at Azure front door, it will be decrypted and then goes through WAF inspection. If a request has, after pass all the inspection, considered as legit, then WAF will forward the request to the backend, to one of the backends. So the Azure front door actually provides global load balancing. So in addition to end-to-end latency optimization, it also provides global load balancing between different sites. You can use priority-based routing or latency-based or weight-based routing to the backend. And there are 4 actions supported here. You can use block, allow, or redirect to a honeypot, for example, or you can just log, monitor the request only. So here is an example of how you would use WAF with front door to protect your web applications. It's a very simple use case. So basically, a website is hosted in Azure Web App from App Services, and then your data is stored in Cosmos DB. So you can just simply enable WAF, define a policy associated with a front door front end, and then CNAME. So let's say your company's domain is contoso.com. You can CNAME that to the front door instance. Then you're protected. After everything is validated, you should really lock down to your backend. And here is the web app. Only allow access from front door, so the attackers cannot arrive, cannot send traffic to your website directly. The benefit of stopping to have the WAF enabled at the edge is to stop the attacks where it's coming from without bringing that to your application. So now let's say your application is really highly successful. So you want to add a second site for business continuity as well as for latency optimization for the users close to your second region. So here I added another region. You don't need to do anything to the WAF policy because the WAF policy is actually globally deployed, applied to all the edge locations. The only thing you need to do is to add your second region to your front door configuration. So now you have 2 backends instead of 1. There's no configuration change on the WAF side. So I'm going to use the next couple of minutes, show you a quick demo of how to configure a WAF and apply it to a front door front end. So here, if you go to Azure portal, you're probably already familiar with portal, so you can just find web application firewall. So this one is from Microsoft. There are quite a few other options as well in the marketplace. So go ahead and then you can create a policy. So in the policy creation screen, you can choose whether you define a WAF policy for global that is integrated with front door or for regional that is integrated with application gateway. If you choose global, then the location, so this here, the location resource group location is grayed out. And if you choose application gateway, you will need to choose which location that you want to apply your policy for. For example, here is choose East Asia. So I'm going to show you use front door, and then this is a standard. You can use your define your resource group, and then just give it a name. It says web 1114 demo WAF, for example. So this is actually all you need to do if you take everything in the default configuration. So the only thing you need to do is you can go association. So take everything as default, and then you can associate in the association. You can associate it to a front door host, and that's usually it. So usually takes a couple minutes. You can review and then create. In the interest of time, I'm going to show you a policy already I created earlier to show you how some of the settings. So in the policy settings, this is a global setting. You can define your web application in the detection or prevention mode. In the detection mode, there's no action taken, so it will be just logging all the requests. We see some customers use detection mode first to find out what kind of traffic pattern they're getting and if there's any attacks going on, or if there are any false positives. So usually we see them use detection first, and once everything is validated and change into prevention mode. You can define a redirect URL. So this is in case you want to redirect matched requests to a different site or to honeypot, for example. And then our default response code, when a WAF block request is 403, you can define your own. Same thing with a response body. You can define a customized response body. By default, we'll show you a ref string that give you just basically is a GUID, a bunch of numbers and letters to show you which was blocked, so you can help us troubleshoot by default. In the managed rule set, there are two of them are selected. One of them is the pre-configured default rule set. In the pre-managed Microsoft default rule set is by default selected. And then I also choose the bot manager. So here, for example, you can see the good bots and good and bad bots. And then you can change if you click on one of the categories. Here is unverified search engine crawlers. So currently action is log. You can go ahead and then change the action into block if you so desire. And then a quick couple of examples on customer rules. So here I have a very simple block US rules. So for this website, if I say if the request URL contains a contact, then block the site. And then the next one is a rate limiting. So there are two types of rules I talked about. Rate limiting is actually you can use the same kind of match conditions. For example, your URL is for the store up node, but then the only difference here is you define a rate duration, that whether it's 1 minute or 5 minutes. And then the threshold, you can define, 1,000 or, 500. Usually we recommend, around 100-ish. So the priority is defines the order of execution. So the smaller the number is, the higher the priority is. If a request is matched at higher priority, then the further the inspection will stop. You will exit WAF and the request get processed and forwarded to the backend or blocked. So that's it. The demo I show you is right here. So this is the website. And as I show you, if you go to the contact, and that's the one we defined the geo blocking, because this website is meant for non-US access only. So if I go to the origin, so this will show you this website is for non-US access only. If you enable your WAF rule, so it go ahead and then it's blocked. And with the SQL injection, you can see they're already blocked. So that's all. That's the quick demo. And I'm going to hand it over to Amit. Hey, go Amit.
Hey, thanks, Teresa. I'll start projecting from my side and I'll take over. Thanks. So could someone confirm that they can see my screen right now?
Yeah, we can see it.
Okay, cool. So thanks, Teresa. So the biggest announcement we made recently at Ignite, which Teresa referred to, was sort of a unification of the WAF policy of the WAF, Azure WAF. Instead of thinking about Azure WAF as Azure WAF at Application Gateway and Azure WAF at Edge, this unification allows you to create Azure WAF policies and then apply those WAF policies on either at Edge or on in region Application Gateway. And we are working very hard to ensure that there is a consistent API, consistent UI schema, and that all the features are converging towards the same. And towards that, and we have made quite a bit of announcement at Ignite on the application gateway side. So let me just give a quick overview of what in-region web application firewall is. So as you know, we had application gateway in GA since 2015, and in 2017 we launched WAF at application gateway, which was exclusively in-region WAF. Uh, Now we have made in April of this year significant improvements on the WAF with the introduction of the V2 SKU. Now, V2 SKU is a ground up rewrite of the V1 platform, the earlier application gateway, as well as the WAF platform, and it offers many advantages over the V1 SKU. Most significant are that it is by default, it is zone redundant. So if you are deploying an application gateway with WAF or just plain application gateway, it would span multiple zones if that region supports zones, and you get to choose which zones you want to apply this application gateway into. So you can choose one zone or you can choose three zones, and application gateway will get deployed into those three zones, and even if a zone goes down, your application is protected. uh, we also introduced static IPs, and now you get a stable static IP which will survive even if you stop and start the gateway. And if you delete the gateway, even then the static IP is coming from your own subscription. So then you can take that same static IP and apply it to another gateway or apply it to some other VM or do something else around that. One of the biggest improvements was the reduction in the provisioning and configuration update time. So in most regions, the new gateway, instead of the earlier 20 minutes, it should come up in around 4 to 5 minutes time frame. And all update operations, including those on WAF, if you are doing through direct APIs, they should take around 30 to 40 seconds. And if you are doing through portal, it should take around 40 to 50 seconds. And that earlier WAF operations were especially slow because it required a restart of the WAF engine. So we have optimized that, and it takes 40 to 50 seconds if you are doing it through portal. We have added support for auto scaling on the new platform. So WAF benefits from that as well. So now as traffic increases, your WAF deployment will increase in its total number of instances it has deployed to serve that traffic. So it seamlessly increases in response to the increase in traffic. We also added in GA support for CRS 3.1. This was done in July end timeframe. Earlier, we were doing CRS 2.2.9 and CRS 3.0 rule sets. CRS 3.1 is improvement over CRS 3.0. It reduces false positives quite a lot, and it also has better performance for most of the regular expression operations. So it is available as an option today, and we are working towards making it the default choice. So even if you don't choose, it would be 3.1. If you still wanted to go ahead and choose 3.0, then you can choose 3.0, but for new gateways, it will be 3.1. For existing gateways, we will not change anything. It will continue to be whatever it is, but you will have a choice to upgrade to 3.1 if you want it. We also integrated with Azure Sentinel, which is a SIEM solution. I'll show you a little bit in demo. One another aspect which was improved on the V2 side was that we see a lot of customers using the WAF in detection mode and then switch to prevention mode. And we were always asked that if it's in detection mode, why should be it inline to the traffic? Can it be doing that offline? So we have made that change. Now, if you are running the WAF in detection mode, it will not add anything to the latency. It really works on a mirror of the incoming traffic. The incoming traffic is passed to the backend after proxying and all the validations is done. And then a mirror of that goes to the WAF engine, which analyzes it and logs all the issues. There was earlier question on the WAF log, so I'll cover that in the demo as well. And then there are numerous smallish changes, like, we increased the listener count from 20 to 40, and file upload size limit has been increased from the earlier 100 on medium, 500 on large, to 750 MB on the V2 SKU. And we also introduced a few metrics. So let's go forward and talk about the recent announcements which we made just really we made it start of November at the Ignite conference. So one of the most often asked features was that uh, that customers wanted not to have a global WAF policy on an application gateway, but really a customized WAF policy, which is on a per listener, per site basis. So today, if you remember, App Gateway can support up to 40 listeners or 40 different sites on the same application gateway. Now, having a global WAF configuration obviously has its limitations because customers can only choose one particular policy, and that particular policy is applied to all of the WAFs, all of the sites on that WAF. So now we have made it configurable so that you can attach a policy to a site. And we have also gone a little bit further ahead on that. And we also support within a site, you could have a URL path map. So App Gateway supports routing within a site to different URLs to different backend pools. Just to give an example, if your site is contoso.com, then you could have a path map which says contoso.com/audio could go to this particular backend pool, whereas /news goes to another backend pool and /API goes to another backend pool. So you could have different policies at different URL paths within a site as well. So not only you can have different policy at different sites, but within a site, you can have different policies within different URL paths. So this is in public preview. Portal support is already available in some geographies, and it is rolling out as we speak in other geographies. So depending on your geography, you might not see it. I will share a specific link which will opt you into the policy so that you can see it irrespective of your geography. But we expect the rollout to complete within next few days, and by few days, like literally 3 or 4 days kind of time window. So this is already available in portal at this point. We also announced public preview for geo filtering capabilities. So WAF, as Teresa said that earlier, that we support managed rules, we support custom rules, and WAF at front door always supported the geo filtering option on custom rules. So we are announcing that option on the in region WAF as well. And this is completely integrated with the custom rules. So the same way as you created your earlier custom rules, now you can create a custom rule which says allow traffic only from a particular country, or you could also say block traffic if it is coming from a group of countries. And we are updating these geo-filtering database, which we have very frequently. So anytime if there are more IP blocks added or something's changed or they get transferred, we would come to know about these as well. So this is also available in public preview at this point of time. One thing important here is that you can choose where to do the geo IP filtering. You can do it based on the client IP address which we see. So this is basically this is not the X forwarded for header. This is just the client IP which we see when a request comes to us. So if you're coming from CDN, we would see that CDN's client IP. So if you want to do that kind of filtering based on just client IP, you could do that, or you could choose X forwarded for header and then apply a geo filter on the X forwarded for headers IP as well. So that option is in public preview at this point of time. We have also are announcing integration with our own IP reputation engine. So this is our own internal as well as external data sources collated IP reputation engine, which tells with quite a lot of confidence whether this particular IP is part of a botnet, or is it or has it been triggered very recently, has it been flagged recently and marked as someone who is sending spurious traffic. And the data sources are external as well as data we collect from Windows Update, Bing, our own threat intelligence data. So this data is currently being refreshed daily. We are working on making the refresh happen hourly. This is also in public preview. Now, if you see the managed rules, you would see the bot protection as a completely new rule set. So if you think about application gateway managed rules, custom rules are the ones which you write and you define. But if you think about the managed rule sets from our side, you will see now two options. One is the OWASP category of rule sets, where we offer three different rule sets: CRS 2.2.9, 3.0, and 3.1. So that is the OWASP category. And with this release, we have added the bot manager category, where you will see just one option, which is Microsoft's threat intelligence based data. So you can choose this as in addition to the OWASP category. So in this example, for example, if you see the slide, you will see that there are two managed rule sets selected at this point. One is the OWASP 3.0, and the second is Microsoft Bot Manager Rule Set 0.1. This is in public preview at this point of time. Again, all of this is being configured through WAF policy, right? So you do not need to enable the GeoIP feature or the bot mitigation feature on all the sites. You can choose a specific site. You can create a policy with bot mitigation and attach that policy to a specific site, and only that specific site would be uh, uh, protected with bot protection feature. Or you could also attach the WAF policy to the application gateway, just like earlier. And in that case, all the listeners in that application gateway will inherit that policy by default. You can override that policy again on a specific listener. So this was also in public preview. Now, with that, I wanted to switch to a quick demo of what we have done. If you are familiar, we have also integrated this whole setup with Kubernetes service. So Azure Kubernetes service has been also integrated with Application Gateway. Application Gateway can act as an ingress controller for the AKS clusters. So what this means is that you can have one particular application gateway which is outside of the AKS cluster, but it is integrated with that AKS cluster. So we install a Helm using Helm chart. We install a pod on the AKS cluster, and that that pod basically listens to all the events within the AKS cluster through its API server, and programs the app gateway on behalf of the AKS cluster, so that a user doesn't have to do anything. So for in this example, we are going to create a website. It's called getpacket.com, and it will be integrated with two different backend pools within a VNet. Now, the backend pool one is based on VMs or VMSs. This is the old model. And then the backend pool two is actually migration of that same site to AKS. And now you would see that the app gateway is serving traffic both to the VMs and to the VMSs and to the AKS based site from the same application gateway. And it is protecting at least one of the paths with WAF policy. So that is the demo. So with that, let me switch to the application. So I have a resource group where I have created most of the provisioning heavy entities. So for example, this is a simple resource group where we already have an app gateway created, and there is already a AKS created. Application gateway is using a key vault to retrieve certificates, so that your DevOps team do not need to have access to the SSL certificates. So that integration was also announced in GA at Ignite timeframe. So this app gateway is only referencing to a key vault certificate, and your security teams can go and configure the key vault with the appropriate certificate and certificate renewal policy, so that when the certificate renewal happens, application gateway will retrieve the latest version of that certificate automatically without you doing anything. So that eliminates all the earlier troubles of thinking about what happens if my certificate expires. We are probing that key vault for newer versions every 4 hours, and you can always override, and you can always say, go retrieve the latest version right now. So though both the manual and automatic probing capabilities are there. So just continuing on the demo, let's see the demo app gateway. So the app gateway currently has a very simple listener. There is no Kubernetes integration, you can see that it has a getpacket.com and getpacketssl.com. It is configured with automatic redirection. So if I go and if I say http www.getpacket.com, then it should redirect me directly to HTTPS automatically. And if I see the certificate, you would see that this certificate is old getpacket.com. And you will see that this is a self-signed certificate. So it is going to a particular setup which is based off virtual machines. Now, you can very easily go to the application gateway and go to this particular listener and change your uh, uh, certificate, and instead of retrieving it from a PFX file, you can always choose a particular key vault, and we would retrieve the certificate from that key vault. It will load the certificate, and you can choose that certificate and hit save, and it would retrieve the certificate from the key vault and configure itself with that. Now let's go to the rules. If you see the rules, there is just one redirection rule, which I just showed you, and it has just one simple old store rule, which is saying any traffic which is being received on store goes to a VM backend pool, right? So if you see the application right now, if I give it a store path, it would go to a backend which is hosted on a virtual machine. So how do we integrate this to AKS, and also how do we put WAF in front of AKS? So let's go to the shell, and I'll show you what the configuration over here is. So you can see, if you see the Helm config, when it is installed, you have to create a Helm config and tell AKS how to reach the application gateway. So here, if you see the Helm configuration, let me increase the size a little so that it's easier to see. If you see the Helm configuration, you will see that the Helm configuration tells the AKS that this is the application gateway to use. An important property is this shared true. Shared true is basically telling that typically when you are using any ingress controller, it takes full control of the entire ingress object. But that's not what we want. We want it to only modify a certain portion of the application gateway and allow the gateway to send traffic to the older pools like virtual machines or some other deployments you have, and not to override that older deployment. So that's why you have to say shared is equal to true. And that's it. Let's also see the prohibited YAML. Now you see in the prohibited YAML, you can see that we are telling the ingress controller that do not touch anything on this host name get packet with /store/star. And this is important because as we saw, we have an application running on VM and we don't want to override this particular path on this host. So this instructs the ingress controller to not touch this portion of the ingress, but allow to do anything else on the other portions. Now let's do on all of the AKS deployments, the way you configure ingress is through the ingress YAML object. And here, the only two changes you require to do is tell the ingress that your ingress object is actually an application gateway and that it is enabled with WAF. And which WAF policy to use? It is this simple WAF policy which is being described. Let me just show you that policy very quickly. This policy is already pre-created, but the creation steps are exactly identical to what Teresa showed. So this is a WAF policy. It has a few policy settings. So it has settings on exclusion lists. It has a mode, whether it's running in prevention or detection mode. The names are very self-evident on what it would do. Exclusion lists are another avenue to do false positive reduction. So you could say that I want to exclude a particular header and I want to, if the header equals certain value, like say AAD token, let's say if it was AAD token, then I wanted to exclude that. I will not save that right now. But you can also have parameters on what is the maximum file size or post request size which you want. And then you go to the managed rules section where I have configured both the OWASP 3.1 rule set, which is the latest rule set, as well as bot manager rule set, which has been declared in public preview just now. And if you go to the custom rules, I have in the custom rules a simple rule, which is the blocked geolocation. And the key thing over there, all this has been, so this is the exact same UI you would have expected, you would have seen earlier, which Teresa was showing. But the same WAF policy, exact same experiences with application gateway. And now for now, you can see that this application this WAF policy is not attached to any application gateway. So if I just expand this a little, you will see that you get a choice to associate this WAF policy to an application gateway, and you also see a list of gateways with which this WAF policy is associated, and that list is empty as of now. So that basically allows you to create a WAF policy and associate it to multiple different application gateways so that you have the same WAF policy across. So as of now, this is not integrated with anything because we have not applied this. So you see that we have the ingress, which is telling that use application gateway as an ingress, and then a WAF annotation, which is saying use the global policy, which I just showed you as the WAF for that ingress. So we are going to apply this to both the get packet as well as a Grafana listener, which I had created earlier. And the exact same configuration, the same annotation and the same WAF policy is going to be applied to both of them. So let's do. So now we are applying the ingress.yaml, and it should start. Wi-Fi is a little on the slower side over here, but you see that it has created for get packet and for Grafana, both of those listeners which I was talking to you about. It has created the ingress, and now if I go to my application gateway, you would see that it has automatically started updating it. So now what has happened? I haven't changed anything. So what has happened is that if you see the kubectl side of the world, if you see this side of the world, it is running this ingress controller, which I talked to you about as a pod. And this is my counter application, which which is the exact same application which I showed you on the VM, but it is running on the Kubernetes pod. So this ingress controller is essentially applying the changes on our behalf to the application gateway. Now, if I go and see what it has done on the listener side, you see that get packet has not been changed. Get packet is as it is. The get packet SSL and get packet, these were the two earlier ones we saw. And it has added another listener for the Grafana side. Now let's go to the rules. If I go to the rules, you will see that the old store rule has not been touched. Redirect rule has not been touched. And it has added another rule for this particular get packet, which is going to a different backend pool. And this backend pool is essentially the AKS ingress controller backend pool. Now, one key thing to notice over here is that it is talking to the pods directly using their private IPs. So there is no kube proxy or DNATing required. The application gateway is talking to the pods on their private IPs directly. And we have done a lot of testing, and that shows that it gives you quite a bit of performance boost when compared to going from public to a load balancer to any of the ingress controllers which are installed within the cluster, be it Nginx or be it any other ingress controller. So this is what it has done so far, and it has applied that. So let's see if the application has finished. Yeah. So now if I go to store, I should still see the virtual machine. And if I go to new-store, then I see that it has now started to do Kubernetes, right? And if I try to do any kind of injection, like this is a classic SQL injection. Now my Kubernetes pods are actually are protected by the application gateway WAF v2. This screen, of course, is customizable. You could have your own custom screen, but now it is protected at this point. Now let's go and see the global policy, what changes were made on the global policy. So if I see the associated application gateways, you will see that it has associated it to the demo app gateway, which I was just showing you, and it has printed the listener name. But more importantly, if you see over here, I have this particular domain name get packet. If I try to do store and try to do the same injection, it is allowed, because this is a particular path which is not protected by the WAF. But if I go to the same domain and if I go to the second path within the same listener, within the same domain, which is actually protected by the WAF, then you can see that two paths within the same site have different policies. One is protected by WAF and one path in the same site is not protected by WAF. So that is another thing which I wanted to show. There were earlier questions on, can you give some details on the logs? So I just wanted to quickly take some time and show you what kind of logging is available. So anytime these rules are triggered, we log all of those details into a diagnostics log called Web Application Firewall log. And you can see all of these details in every single log. So it would tell you what was the client IP, what was the client port, which URI were they accessing, which particular rule in which rule group was triggered. So this example is OS 3.0 rule number 9200350, and the message is host header is a numeric IP address. Now, most important part of that is that we also log three different things which could be of benefit to you. One is we log what was the pattern which WAF was trying to match. So in case of custom rules or in case of geo filtering, these don't matter because they are not regular expression matches. But if you had any managed rules or if you had written a custom rules with regular expression, it will show you in the message what was the pattern it was trying to match. And in the data segment, it will also show you what really matched this pattern. So it is looking for this pattern and this data matched that pattern. And it also prints details. Because these are community mod security rules, it also gives you details of which mod security rule was matched and which line was matched. So if you wanted to do further analysis, you can do that. And then also we have added details for which policy this particular match was and the scope, whether it was global or whether it was site or whether it was a URI path. So that concludes all the details on the logging aspect. And of course, all these logs are going to log analytics. So you can do all kinds of SQL-like queries, like give me top 5 attacking IPs, or give me top 5 URIs which are being impacted, or give me top 5 or top 10 attack patterns, like what are the top rules which are being shown. And we have also integrated this the same log analytics with the same diagnostics log and log analytics with Sentinel, and that gives you quite a dashboard, customizable dashboard, which will give you quite a lot of details, like how many are SSL, what kind of user agent has been used, what HTTP methods are being used, and what are the URL addresses which are being attacked, and what are the client IP addresses who are doing most of the attacking, what events are there, and so on. It also gives you details on what are the rules which have been attacked, which have been triggered, and all the events on the firewall. So all of those details are also natively integrated with SIEM called Azure Sentinel, our native CM solution. And you can also put it in log analytics, or you can send them to Event Hub and send them to using a connector. You can use any of your own CMs of choice. That option is also available. So that concludes what I wanted to present. Let's go to key takeaways and conclusions. So one of the key takeaways we would like everyone to remember is that any mobile web application, you should always think about having a WAF in front, for all the reasons mentioned earlier, that these attacks are on an increasing trend and you do not want to expose a publicly available website without a WAF. Now, WAF is a unified WAF. You can attach it to edge or you can attach it to region. If you are attaching it to the edge, it offers you acceleration. It offers you protection to multiple sites at the same time. If you are attaching it to in region, it protects within that region. You can also protect hybrid scenarios where you can protect your VPN or express route connected on premises, or resources within that virtual network, or any public IP accessible resources either within that region or even outside of Azure. And the key message, another which you should remember, is that WAF is one component in the whole puzzle. Always think of defense in depth. Always think of having DDoS service. If you attach it to the VNet, then you have DDoS and WAF protection both. WAF at edge has inbuilt DDoS capability. Think of using Azure Firewall. Think of a comprehensive NSG, ASG for your comprehensive segmentation. Use private links for private secure access to storage and other services. The key message over here is defense in depth. Think there are many different products available to you. Use all of them as your requirements are, and complete the picture of DDoS, WAF, firewall, segmentation, private link, and so on. We also have the combined documentation at the location, and there is also a feedback Azure link. I would highly encourage you to submit feedbacks for any missing capabilities or features and things which you want to for us to work on. And that is everything. Thank you for your time.
Thank you, Amit. We believe that we answered all of the questions that were posted in the IM window. And in case you have additional questions, you can always visit us and post them at aka.ms/Azure Security Community, where you'll able to ask questions in this forum. And if you're listening to this after the fact of the recording, that's also a great place to ask questions. I want to thank all of those who helped answering the questions through the IM window during the call. Thank you, Teresa and Amit, for a fascinating presentation. Most of all, I want to thank all of you for being part of our community and for joining us in these webinars. We hope to see you next time. Thank you and goodbye.
Thanks, everyone.
Thank you.